Welcome to Mathematics Anyone. Today I will teach you college calculus. The topic that I took is the substitute rule. Substitute rule is continuation from the last class, college calculus. Okay. Here I will show you 4 steps how arrive to the substitution rule. Okay, and then I will solve a couple of problems applying the substitution rule, of course. Okay, so let's start it then. The first step here to arrive or to understand the substitute rule, we have to, for instance, the number 1, step 1. We have integral of 2x times square root of 1 plus x to the second power, differential x. Okay, this is the number 1. The second step we will have integral of 2x, again 2x, but now the same thing here, square root 1 plus x to the second power, differential of x, but now we have equivalent to, this is must to be equals to integral, of course, integral of again square root 1 plus x to the second power, then 2x differential of x. Here we have to write integral to square root of u differential of u. Okay, that's actually the step number 2. We are looking for the substitution rule, so we have to make a 3-4 step to arrive to the substitution rule. So here we have to simplify this. How simplify here? And this integral, so substitute right here. Let's write it. Here we have to write 2/3 right here is going to be equals 2/3. Then u to the 3/2. 3/2 is a power. It's a power here. Plus c. Now equals 2/3 of 1 plus 1 plus x to the second power. This 3 to the 3/2 power. 3/2 power, same thing here right here, plus c. Look at the formula there. So here at this moment, using remember the change rule here, I will write it using the change rule. Change rule is remember I show you last class here to the in this to different to the final function with the question 2. This to the final to equation 2 to the equation 2. All right. Some idea here. So then we have to write Then now differential now over dx equals, it's a long process right here. I will do it here, this space. Now the final step. So open crochet right here, and then let's write 2/3. Remember this change rule. We have to remember the change rules at this point right here. Then we have to write here, we have 1 plus x to the second power, right? To the second power, to the 3/2 power, see, 3/2 power plus c. Okay, all the parts of the problem plus c, and then close here. We have to close the crochet. Then equals 2/3 times 3/2, okay, times 3/2 times 1 here plus x to the second power here to the 1/2 power, elevated to the 1/2 power, times here 2x equals this 2x square root of 1 plus x to the second power. Okay, so we are at this point. I will erase this window to continue another step. So look at here. Here we can write, right now we are allowed to write into this form. From here, let me go to this form. Okay, I will erase step number 2. So I will let me write. So right here, right into the form. Okay, right into the form. This form so this form here, continue here. Let's write the sign, the integral right here of f, and then let's write here g of x, close here, and then times g prime of x, times dx. Okay, we have to observe here that I will erase the bar of all the information and the bar. We have to observe this. If here, if in this point, if f, a capital letter, prime right here, is equals f. So then I will erase this. Then continuation, we have number 3, step number 3 right here. Number 3, this is 1. Okay, I will not erase number 1. Number 3 right here. Then we will have integral of f, capital letter, prime, of g of x, here times g prime of x, differential of x equals f of g times g of g of x here plus here I'm missing one sign, right? Plus right here plus c, right? Almost done. So 4th step now, because now here I will write because the chain rule, okay, the chain rule is the differential of x over differential of x, and then over crochet. Here we have to write f, capital letter of g of x, of x. Here yeah, two signs right there. Okay, equals f prime of g of x, right, times g prime of x. Okay, so this is step number 3. Now if for instance we made the chains of the variable, or substitution, we have to write I will erase this. If we make the chains, okay, chains of variable. That's very important. Or substitution, or substitution. We have you remember the variables that I give it to you, that I write it before, equals g of x. Okay, right here I'm doing this very slow, step by step. Okay, then from equation 3, remember that here, then from equation 3, number 3, remember I erased the equation number 3, we have how we erase this. Then we have here integral. Let me write the sign right here. It's a very big f prime of g of x, and then g prime of x dx equals f. Here again, g of x plus c, right there, plus c equals f again of u, remember, of u plus c equals here equals integral, it's continuation here, integral of f prime of u, differential of u. Okay, or in other words, or writing also, or writing f prime is allowed this way, equals f. We get let me erase right here, and then I will write the formula with go over here. So write the integral, the sign integral. So write f g of x, yeah, and then g prime of x, it's dx right here, dx equals integral f of u differential of u. Okay, almost done, almost done. Then here I will erase everything. So we are right here. This is very important. Very important. Then we have prove the for you win rule. So from here we have prove the for you win rule. So we will have number 4. This is the substitution rule. Substitution rule. That's the one that I wanna see. Okay. So now, if, for instance, if we have u, remember I explained it to you. U is equals g of x. U is equals u x is differentiable to differentiable function. Yeah, function. All right, that's a differential function whose range. So here, let's write here range. This another point important is integral like c. Let me write down integral. Let's write integral I and f. Yeah, and f. Oh no, not capital letter, f. Lowercase. Okay. Is continuous yeah, write it like it's continuous on the integral. All right, then. So this is the rule. Then let me write here the rule, the substitution rule. This is a number. Substitution rule is right here. Integral f. This is the substitution rule. G of x. Yeah, g of x. Let's write it like this. G prime of x is equals integral of f of u differential of u. Okay, that's the rule number. This is a number 4. Okay, now let's apply with this rule. This is the change, the substitution rule. So now let's apply how this works in a problem. I will solve two problems. Okay. Let's go to the examples. Our first problem. Find. Let's write this problem. Find. Let me integral of x to the third power. Cosine of x to the 4 plus 2 differential of x. Okay, that's our first problem. Problem number 1. Okay, the solution here, we have to make the substitution. The substitution u equals x to the 4th power plus 2. The substitute, because it's the differential. This is the differential. This is the differential differential like equals x to the 4th power plus 2. Okay. No plus 2 right here, just write it differential of x. Yeah, differential of x, like that. Okay, that's the step. Which apart from the constant, what is the constant number 2? The constants. Factorization is a fact 4. We have next we have to fact 4 here. Fact 4, yeah, here occurs in the integrals. Here the integral. All right. And this way we have or using here, using it's better, using x to the third power, differential of x equals 1/4. Yeah, 1/4. X equals 1/4, and the substitution and the substitution rule. Let's write it right here. Rule. The substitution rule that which I wrote it for. Remember, I wrote the substitution for you. We have then. So we have. Okay, let's integral. I will erase. Let me try to do everything right here, because I don't want to lose. We have. Let me write right here. So integral. I write integral right here. X. So now x to the third power. Okay, step by step. Cosine of. I'll write the problem of x to the 4th power plus 2 differential x equals, this is equals integral cosine u, yeah, we are using u, times here, time, at this point is times 1/4 differential u, okay. This is equals 1/4 again, 1/4 integrals, yeah, integral cosine of u differential u, okay, du. So now we are simplifying right here. Yeah. How simplify here? Let's write it. I'm gonna use this different color. 1/4 right here. 1/4. Okay, whereas sine u plus c. Okay, we are here right now, right? So equals. This is equals. Then 1/4 sine of course x to the 4th power plus 2 close parenthesis plus c. All right, so final stage we have here to return. This is the final stage. We have to return to the original variable here. The final stage here. This is unbelievable, right? But the final step, we have to return to the original variable x. See? We have to return to the original variable x. Okay? That is the application, the substitution rule in this problem. Okay? In this problem. So that's the solution. Let me show you another one. Let's solve another problem. Okay? Let's solve another problem. And then to improve the knowledge or skill how apply the substitution rule. So our second problem is evaluated. We have to evaluate it. Evaluated integral of a square root of 2x plus 1, 2x plus 1, right? dx. Okay, this is our problem. We have to evaluate it. This is very simple. So what is the solution? Let's work in the solution here, all process here. Okay, all this space. So let here let u to the beginning equals 2x, must be equals 2x. All right. 2x plus 1. We have 2x plus 1. So first step. Then let's differential. Then du equals 2 dx. Okay. So here. So dx here, dx or differential of x is equals 1/2 du. I mean du. Okay. Last step by step. Okay. That's the substitution rule. The substitution rule gives the next problem. So the next statement. So integral of, look at this, 2x plus 1, 2x plus 1 dx. Just write it complete. No problem. Must be equals. Equals integral square root u, right? Square root u times 1/2 du, right? So equals 1/2 integral u to the 1/2 power. This is 1/2 power. Oh my god, it's 1/2 power, right there, 1/2 power du. Okay, so now simplify from here. Simplify. This is could be one solution. Here we have now what easy from here. 1 is equals 1/2 times here we will have u to the third power 3.5 power, and the value divided by 3.5 plus c. All right. Then this equals 1/3 u to the 3.5 power plus c. All right. The simple way to simplify it is smaller. Here we will have 1/3 of 2x plus 1, 2x plus 1 to the 3.5 power plus c. Okay. So this is the solution. Solution 1. Let me work with the in a different another solution. We can solve problem by a different way. So this is a one way. So let me show you. Let's write here solution 1. This is two solutions. Solution 1. Okay, got it? Let me erase the solution 1 and let's work with the solution 2. It's almost the same, a little bit different. Solution 2, number 2. Okay, let's start it. It's another possible solution. It's another possible solution. It's another possible solution is u equals, it's another possible, okay, right? 2x plus 1. 2x plus 1. Then here, let's write du or differential u, differential equals differential x divided by square root of 2x plus 1. 2x plus 1. So here we will have dx, then dx equals square root 2x plus 1. 2x plus 1 here, and du, not dx. Du equals u differential du. Okay, right there. So now, or also here, observe that in this u to the second power is equals 2x plus 1. Okay, observe this. So then we have to write du equals, du equals here 2 differential of x. Alright, so therefore it's another person. Therefore like conclusion, integral of a square root of 2x plus 1 dx, of course, is equals integral u times u differential u right here, okay, equals integral u to the second power differential of u. Okay, now just simplify right here. Simplify. You simplify here, you will have u to the third power divided by 3 plus c. Okay, equals is 1/3 here, 1/3 equals 1/3 of 2x plus 1. Remember another solution to the 3 half power. 3 half power plus c. That's the second solution. Okay, it's right here. C is very similar to the first solution. This is another possible answer. So this is the way how work the substitution rule. This is in the way which we apply the rule in integral thing. Okay, so I hope this class become helpful in your homework or in your classroom, or improve your knowledge or your skill in this area, college calculus. Remember, our class is continuation from the last. This is the substitution rule, and before we know the change rule. Remember, we worked with the change rule the last class. So now it's a continuation to that class. So now use the substitution rule. So I show you two examples. Try to help you in your home, or you actually in general